In this video, I'm going to go through the Topic 6 quiz number 2 review that's posted on Google Classroom. So for this quiz and the unit test, there's not going to be calculators allowed because of the trig functions, and it's based on your knowledge of the unit circle, not your knowledge on how to type something into the calculator. So for the first 3 questions, those are coming from section 6.2, where we talked about coterminal angles and reference angles. And so for the first question, it's asking us which of the following angle is not coterminal with the other 3. So remember that in general, for coterminal angles, they're a revolution away from each other, meaning that we add or we subtract 360 degrees to figure out coterminal angles. So if I look at the first angle, it's acute, and so our goal should be to kind of get the other angles to their acute counterparts. So if I have 67, what I could do is do like 67 and add 360. And if that equals one of these, which really it's just 427, then I would know that A and C are coterminal. And then that would help me start to eliminate what can be the answer. So then it would either be B or D that are not coterminal. So if I add 360 plus 67, and again, I'm taking 360 because that's a full revolution, and then just adding the angle that I get, that gives me 427 degrees. And so since when I add that, I got C, that means that these 2 angles, A and angle C, are coterminal. And so then one thing to think about is if I were to add 360 to B, would I get 67? Or from D, if I were to subtract 360 from 247, would I get 67? So ultimately, now that I know that these 2 are coterminal, I'm trying to figure out if I can get 67 by adding or subtracting 360 from each of them. So if I have a positive angle, if I wanted to start with the larger ones, I would have subtracted 360 from 427, but I can also add 360 to a negative angle. So if I'm going to add 360 to negative 293, I'm really subtracting 293 from 360. So when I'm subtracting, I am lining up my place values. Since I have to subtract 3 from 0, I need to borrow from 60. So I had 10 minus 3 is 7. And then my 50 minus 90 isn't going to work too. So I'm going to have to borrow again from the 100. So I have 15 minus 9 is 6, and then 2 minus 2 is 0. So this is 67 degrees. So that means that negative 293 is also coterminal with those 3. And so the strategy that I would give you is start with the acute angle, add 360 to the acute angle, and see if you get one of the other angles. And then I would take the negative angles, if there was more than 1 or 1, and add 360 to that. Or what I could have done too is I could have just worked with the 67 and done 67 minus 360. And so remember that we still stack with the number with the larger absolute value on top. And so if I were to do that to add 67 to negative 360, I would have 10 minus 7 is 3, and then I would have to borrow here. So then 15 minus 6 is 9, and then that would be negative 293. So that would be another way that I could have gotten the 293, just working with the 67 and adding and subtracting. So I would pick the acute angle and do that. Is another good strategy. So that means that D is the correct answer, that D is not coterminal with the other 3. And a way that I could check that is by subtracting 360. So if I did 247 minus 360, I would have, 3, 5 minus 4 is 1. I would have negative 113. And so see how that's not any of the other angles in my options. So I'm drawing the angle described in question 1 in standard position, and I'm going to label the negative angle and the angle between 0 and 360. So my negative angle is my 293, and the angle between 0 and 360 is 67. So I want to draw a 67-degree angle, and I'm just estimating it. So remember that our initial side is always the positive x-axis. And then if this is 90 degrees, 67 degrees is somewhere closer to 90 in quadrant 1. So that's what the angle would look like in standard position. I also need to label my positive and negative angles. So the positive angle is 67. So 67 degrees is going to go there. I'm drawing the arrow going counterclockwise. To draw the positive, to draw the negative 293, I'm going to make the circle go clockwise. So my arc goes clockwise, negative 293 degrees. So that would be the correct diagram for question 2. Question 3 is asking about reference angles, and we were given formulas for finding the reference angles that in in each quadrant we can find theta by knowing either the reference angle in quadrant 1 or by doing 180 minus the reference angle in quadrant 2, or by doing 180 plus the reference angle in quadrant 3, or by doing 360 minus the reference angle in quadrant 4. So if we read what they're telling us about this angle is that a reference angle is 43 degrees and its terminal side lies in quadrant 3. So the end of the angle ends up in quadrant 3. So if I draw in an angle in standard position, so I've got an angle here, I've got a ray here on the positive x-axis, and then my terminal side is in quadrant 3, where this is 43 degrees. Okay, because remember that reference angles always touch the x-axis. My formula is intuitive. My formula, this 180, means that the angle goes 180 degrees, okay? And then it picks up my reference angle. So visually, I can count out those 90 degrees. And so if I'm going around, I'm just adding 90, that's where the 180 comes from. And then plus 43. So if I do 180 plus 43, that will tell me what one coterminal angle is. So that's 223 degrees. So that means that C is a correct answer. So if I think about positive angles, that will eliminate any angle that's positive and less than 360. So I know that those cannot be coterminal because they're all still on the unit circle, and so they're not going to fall in the same spot. So what I have to figure out then is what is the negative angle. And so remember, to find the negative coterminal, I'm going to subtract 360 degrees from 223. And so since 360 is larger, I'm going to place it on top when I'm stacking with place value. But I'm still going to subtract. So if I'm subtracting 223 from 360, I'm going to borrow from the 60. And so it drops down to 50 and 10. So 10 minus 3 is 7. 50 minus 20 is 30. And then 300 minus 200 is 100. And since the 360 is larger, it's going to be negative 137 degrees. Remember that one way to kind of check to make sure that you're correct is if you're wary about your subtraction, is if you were to add these two together, so 3 plus 7 is 10, and then 2 plus 3 is 5, plus 1 is 6, you should end up with 360 if you ignore the idea that that's negative. And so that's a way to check that you actually have two coterminal angles when one is positive and one is negative. For number 4, we have what we talked about in section 6.3 day 2, and then for 5 through 10, it's what we talked about in section 6.3 day 1. And so for this question, we're given a trig function sine and a quadrant 4, and we're asked to find tangent, another trig function. So if we remember, all students take calculus to remind us what's positive in what quadrant, and we think about this as in quadrant 4. So in quadrant 4, cosine is positive. That means that tangent is going to be negative. So cosine is positive, so that means that either of the others are going to be negative. So the quadrant piece just tells us whether we have a positive or negative answer. The last piece is finding the values. So tangent is y over x, sine is y over r. Okay. So we know that this is going to be -3 because it's the y coordinate of the point that corresponds to the terminal side of this. And so remember that x squared plus y squared equals r squared. That r is the hypotenuse of the triangle drawn in the unit circle. So if we do x squared plus 3 squared equals 5 squared, you might recognize that this is a 3, 4, 5, right, triangle. So we should get 16 for x squared. 25 minus 9 is 16. So if we take the square root of both sides, then x is 4. Okay. So tangent is y over x, so tangent is -3/4. The last questions are all involving the unit circle. So one thing that I would suggest as you go through on your quiz is write down what each of them correspond to. So cosine is x, tangent is y over x. Cosine is x, tangent is y over x. Sine is y, tangent is y over x. And so any of the ones where it's just cosine or sine, they're easier just reading the unit circle. So cosine of 30 degrees, we would find 30 degrees on the unit circle. And then the answer is just the x coordinate. So the answer is radical 3 over 2. So cosine of 30 degrees is radical 3 over 2. Let's look at cosine of -210. So this one's a little more complicated just because 210 is negative. So what you want to do is you want to add 360 so that you can find its positive coterminal. So 360 minus 210, if I'm adding 360 to 210, is 150 degrees. So that means that this point here corresponds to -210 degrees. Remember that we talked about visually, if I look at where positive 210 is, so positive 210 is here. And so it goes all the way 180 and then one line past. Notice that if I go -180 and then one line past, I end up at that 150. Okay, so you can do that visually to find that point. So since it's cosine, it's the x coordinate. So this answer is negative radical 3 over 2. The last one that's no work involved is sine. So we have sine of 4 pi over 3. So if we're looking at the unit circle for 4 pi over 3, 4 pi over 3 is down here in quadrant 3. And sine is the y coordinate. So that means our answer is negative radical 3 over 2. Oops, wrong spot, sorry. The last ones are all the tangents. So for tangents, we're dividing y by x, so we're gonna have to simplify our answer. So at 180 degrees, x is -1 and y is 0. So tangent is 0 over -1. That's 0. Okay, so tangent of 180 is 0. You have to simplify or you're not going to get that answer correct. Tangent of pi over 2, at pi over 2, x is 0, y is 1. So we're going to do 1 over 0. When I'm dividing by 0, that's when the value is undefined. And then finally, we have tangent of 5 pi over 6. So if we find 5 pi over 6, I went too far. That's the one that we have highlighted here. So it's equivalent to 150. So x is negative radical 3 over 2. Y is 1/2. So we're going to do 1/2 over negative radical 3 over 2. That equals 1/2 times 2 over negative radical 3. And those 2's reduce. So we end up with 1 over negative radical 3, which we can rationalize by multiplying by radical 3 over radical 3, which will give us the answer negative radical 3 over 3. And so that's all the concepts that will be on your quiz. So make sure that you know how to do these problems and that you practice the extra problems that are in Pearson.